welcome to this expert-led workshop, Getting More Out of Aria Operations, it used to be called. Now it's called Aria Operations, Getting More Out of It. So it is Aria Operations. So did you know that maybe 30% of the budget that you're using may be lost due to inefficiencies or lack of overview? And the thing with operations is that we would like to ensure that every cent you invest in operations is put to its best use. And that's what we are trying to do, to stop wasting resources, to stop you from actually not using the resources right. And that's why we have Rightsizing. Rightsizing is a part of operations that lets you stop wasting resources, together with the reclaim stuff that's in there. So reclaiming is all about getting rid of snapshots, getting rid of VMs that has disks lying around that are not connected to any VM and such. But for the Rightsizing, it's more about a capacity engine that lies behind there, telling you that there is something wrong. So I come from Norway. I have been with VMware in 8 years time. I came first in contact with operations when they told me that can someone do the cloud management stuff? And I sort of raised my hand and wanted to do that. So that's like 5-6 years ago when we had version 6, and now we have had version 7, and we're way into version 8. God knows what happens tomorrow, but that's the sort of the day where we will get to know about new stuff and everything. So the main session tomorrow morning at 9, that'll be a good thing for that. With me, I have someone roaming around the room here called William. And William, do you like to say something about yourself? William.
Sorry, I had to wait for the microphone there. Yeah, my name is William Demirny. I'm here to answer any questions and help with you guys if you have any issues that are coming up. As it says up there, I'm a NSX Technical Adoption Manager. So my specialty is actually network and virtualization.
So William has also been one of those cool guys that are writing labs. That's what we do on our spare time. So before we go on, let's make sure that we are using these headphones as we should. If you hear me bad, raise your hand, and this microphone is terrible. I'm sorry.
Do you want to switch?
Maybe. Is this good?
Yeah, it's good.
All right. So be curious, ask questions. Whenever you do this, then someone will come over to you with a mic. We need to repeat the questions for you, so everyone can hear what the question was. And then we'll try to answer it. If we can't answer it, we will be available for you after, so we can sort of go through any scenario that you might have that might be interesting for you. If you want to, you can just go ahead and take the lab and just run through it. But I have something that we need to talk about before we do that. And you can do it in your own pace. I mean, if you're fast on doing labs, then for all sakes, just go ahead. I'll do some of the lab on top here, and we go through this thing together. So, and then give you some pointers and tips and tricks, and we will shorten down the lab a little bit and go a little bit outside what the lab actually is there. Because you can take this lab when you get home and take it in your own time, whenever you want to after VM Explorer is done. So, have fun, all right? I don't know how much fun this is going to be, but it is serious enough to...
It's always fun.
It's always fun. William is full of dad jokes, so he'll pop in with a dad joke from time to time. Now, we are going to do module 12. So if you see up on the right side there, there's a lab manual contents. That thing, if you click that thing, that you will get you to the modules that's within the labs. So on top right there is a sort of a lab manual contents. If you click that, all of these modules should be independent of each other, so you can go to which module you would like to. This will only start when you have started the lab, of course, but we'll get to that when we get there. And that's about it that I would like to say here. You have these arrows back and forth, and you know this from before. One very cool thing is that we have something called the tech zone. I don't know if you have been here to the tech zone here, but at this link and this code will take you there. It'll take you to all of the hands-on labs that we have and many more information about Aria and anything else. So I recommend Tech Zone for you after you go from here, and if you want to learn more about anything. You have videos, you have stuff to read, and you have the hands-on labs there.
Yeah, Tech Zone's an interesting mix between the straight-up documentation and then kind of the public-facing sales material. So it's going to be somewhere in between there, where you're going to get some technical, in-depth discussion, but it's not all marketeering.
Behind all this, you have a pod, so to speak. It's where you would do all your labs. So behind the scenes here, there's a lot of technology going on there, and there are guys sitting over here that are actually taking care of this, the labs as we use them, and use a lot of time and energy to keep the lights on. The modules that are within this lab are many. The things that we'll talk about in this PowerPoint presentation is taken from my own lab, Module 3, the capacity management lab. So all the images that we see here will be from that lab. I recommend the reading behind that, because there's a lot of reading in that lab. So I recommend to go to that lab later on and have a look. So we're going to do the Module 12, achieve optimal performance with Rightsizing. We're going to talk about the Rightsizing today. So what is Rightsizing? Well, it is a proactive thing. It is something that you don't set and forget. So it's not a one-time work that you do. There is something to do with it at all times. What you are looking for is to maximize your performance efficiency and reduce your cost, of course, because reducing costs is something that resembles with everyone. And we want to do this seamless. And we're going to take a little look on what we're going to do to make this look seamless to us, so we can automate it and make sure that we sort of do the Rightsizing automatically. And that's the part of the self-driving. I don't know, you've probably heard about that when coming from earlier PowerPoints with VMware Ops and Aria Operations. There's always something about self-driving. And self-driving is automating these tasks to sort of make the everyday picture a little bit better. Right, so we're talking about capacity, because capacity is what we are going to use as a foundation to find out, are we oversized or are we undersized? And the whole capacity is everything that sort of is available to us, the total capacity, all the available resources that we have. The users is presently that utilization, sort of the thing that the machine has right now. The VM has this type of resources right now. This is what we're using. So usage and utilization, that's what it has got at the moment. But that could be too little or too much. And if it demands more than it has actually got, then you get a demand on top of that. Then you have contention, because something is queuing in order to make this happen. The machine is trying to get more resources than it already have. So the usage demand is sort of the capacity that we're trying to get. Of course, there's something going away here from overhead of having ESX hosts, and there is something going away for buffer for spikes. There is something going away for HA when you use that. So there are memory disappearing and capacity disappearing out of that. Now the capacity engine. This is really what sort of drives everything that we're going to look at today. So all of this utilization and all of this demand that we are putting on our VMs, they are discovered by operations. Operations does a discovery every 5 minutes on anything that sort of is in the environment. And then you can see the capacity and the demands for everything that we sort of needs to make these workloads run as best as we can. And out of this capacity engine, we get time remaining. What's time remaining? Well, that's the estimated time until we reach full utilization. So the estimated time until full utilization is the time remaining. The time will run out when we are at 100%. That's sort of what we're saying here. The capacity remaining is the available capacity. The recommended size is the optimal resource configuration. This is what we recommend you to do with this VM to make that resource okay. That is the recommended size. And the recommended total capacity, that is something that is required in the future for this. So that's sort of the projection part of it. And when we project utilization in the future, we can have a diagram like this. So this is the current time that we have on the green one. This is historical data. This is how we have understood that this VM performs. And the current time from today, this is today, so to speak. And then the rest of it is projection and what we think it's going to look like. And you can see on top there that the time remaining is, well, that large. And if I go to my next screen, I see that the time remaining is much larger, it's much longer, I mean. And the capacity remaining is quite larger than this one, sorry, that one and that one. You see that they are increases these arrows. And the first one is a setting, this one is a conservative risk level. We are taking into risk that we might run out of capacity. And that is the upper bound. Now you can see that this dotted yellow line that we have here. That's the where it sort of hits. And what makes these bounds, the upper and lower bounds, be wider or not, I'll tell you that in a bit. But for a conservative risk level, whenever that upper bound hits the ceiling, that's where we sort of have reached our capacity. And for aggressive level then, when we set that as a setting, this is policy settings that we'll take a look at. So when we set that as a setting, we are only taking that mean projection, this brown line that we have in the middle here. We're taking that into account and say that, well, there will be longer time before we run out of capacity because we sort of more aggressive. There's more allocation of resources. We assume a higher tolerance for stuff. And we also can have higher consolidation ratios. So that's the sort of the difference between being conservative and aggressive. Conservative is, well, whatever pops up and it sort of moves the needles there, be careful. So what moves it? What makes these bands go, upper and lower bands run? You have the momentary peaks, and that is like a short-lived peak that are not, it's just maybe a one-time occurrence. And it's not significant enough to sort of move that upper bound at all. A sustained peak is more the things that last for a longer time, so that might impact the projection at all. And periodic peaks is, well, cyclical patterns that sort of impact the projection, periodical peaks. So now, let's go to the lab, and let's start up the lab, and make sure that you do the survey after the lab. I would just change the scenery from one PC to another one here. Any questions so far?
So something I get from my customers a lot is, how much data is it consuming when it's making these projections? And the answer to that is, you can either have it do an almost an immediate projection, say use the last week's worth of data and then project out a week, or you could say project back or use last week, month, 6 months, and then you can have it project further out. The important thing is, the further out the data is you tell it to consume, the less relevance it assigns to those. So if there was a spike 6 months ago, but it's been relatively steady state since then, it's going to assign a much lower precedence to that spike that happened 6 months ago. So the more data you give it, you're going to get a more accurate representation, but it tends to smooth out the upper and lower bounds of the performance characteristics that it's analyzing. Do we have a question? All right, I'm going to hand you the microphone.
The projection here, is this for the guest only, or can you do this for, say, the host or even the cluster?
Yes. So you can do it for individual virtual machines, you can do it for hosts or entire clusters. So you can do all three of them.
Basically, that'll be any object within vSphere, sort of. But most often it's a disk, it's a CPU, memory, and such. Hosts, VMs. Now let's go. So the first part of the let's see, control this at all. The first part of the module is to fiddle around with vSphere. And what we're going to do in vSphere is that we're creating an undersized and an oversized machine. And the first part of the lab, there will be a sort of a table that will show you exactly what to do with. Hang on. What I mean is that after you sort of logged in and trying to find this table, this is what we're going to do within vSphere. So you're going to fiddle with those VMs. So you log on to vSphere instead of logging on to Ops. So take a new tab and then go to log on to vSphere instead of VMware Ops. And in vSphere, we're going to find those two VMs, the Linux Dev 0010 and the Linux Dev 0011. And when we find those, we're going to right-click them and edit the properties for it. And on one of the servers, we're going to give it 4 virtual CPU and 16 gigs of RAM. And the other one is going to have just one CPU, and we give it 4 megabytes of RAM. We don't know if it even will start with that, but it does. And after we've done that, we start up these two VMs. If you're uncertain what to do, then the lab module will guide you through it. But basically, it is going into vSphere, into vCenter, logging on there, and do this to those VMs. Then, after we've done that, we'll come back and, well, you can give me a hint, and if you have done it, this, and we'll continue to sort of do the lab. I will also do this. So use Windows Session Authentication is what we're doing to get logged in.
So while we're waiting on that, if you've ever used this tool before and you've ever been a little suspicious about some of the metrics that it's giving you, where it always looks like it's adding 50% or taking away 50%. The reason for that is the VROPS engine tends to be very conservative. So even if you've got a VM that's 90% overutilized or underutilized, it's never going to recommend more than a 50% change to that VM at any given time. The idea being, okay, you may need to take away 24 gigs of RAM, but I'm only going to say take away 12 this time, and then let's monitor it for another week, and then it'll update the recommendation and say take away another 12 or another 6. So that's why the numbers always look very suspicious whenever you're taking a look at it. It's the way it's supposed to operate.
I can't remember which one to undersize and oversize, so I'm just doing what I need to do to this. Right-clicking, edit settings, and on the... I'm really struggling with this volume thing. And one is going to have just 4 megs of RAM, not gigs. It's a really, really small Unix server. And after you edit those, you just right-click it and power on.
Any questions from anybody?
So, if you're finished with the vSphere section, the next little tip is something that we need. Because VMware Ops is trying to sort of find out what has been added or taken away from vSphere during the last minutes, but there we go, okay. So it's trying to sort of find out everything every 5 minutes. The first discovery cycle is sort of making sure that it understands that these have been powered on. The second collection cycle will see to that it actually understands the parameters coming from these two VMs that we are powering on. So to avoid all of this waiting for 10 minutes to make sure that we sort of have collected the data, we will do the following. So this is not in the manual. We will go to data sources, integrations, and under these accounts, we will find vCenter as one of the accounts. We'll expand that, and under the three-dotted menu, the ellipsis there, we will select Stop Collecting. And guess what? We're going to do that once more and start collecting. So this sort of enforces ops to collect, and collect faster than waiting for 5 to 10 minutes for these collection cycles. If it was a production environment, don't do that. I mean, we will need the data coming in from every 5 minutes and that's coming from everything else. But this is a sort of a test environment. We can do whatever we want to. So now the next thing is to find out, do we have anything oversized or undersized? And that's really easy. And in the manual it says, go to the home page, do the capacity and yabba, yabba, yabba. But we will go directly to optimize and then go to right size. That'll take you to the Rightsizing. And if you can see here on the screen here, we have one with a lot of clouds on it and one which is more of a data center on it. And we're going to click the one with a data center on it, the second one. The first one is coming from vRealize automation, sort of telling us that we have connected to something and something is coming in from there. So that's why we see this twice. Now, all in all, you see that there are oversized stuff here, and there are undersized stuff here. And the oversize is, in almost any environment in the whole world, is more and bigger than the undersized environment. So oversized, that's things that needs more resources to run a good optimized environment. And undersized is, I said the opposite now. Oversized is, of course, things that have too many resources. And this is almost every time it's the case that you have too much resources wasted on nothing. So in this case, I have 12 virtual CPUs and 33 gigs of RAM available. Well, I can have 4 new Linux servers on that. Even 2 Windows servers can be running quite good on this. So these are wasted resources that I can use for that. And the same with undersized. Well, I need more resources, but that's not much. I need a gig of RAM. Well, you can take from the rich and give to the poor. That's a window here. So let's go further down here. We just do the scrolling and go down to the workload underneath here.
Hey, Ben.
Yep.
Hey, I just can't shut up over here.
Good.
Sorry, guys. I just want to chip in here. VROps is going to give you data, right? But you need to bring your business knowledge forward to this. Let's take a finance app, for example, right? That runs once every three months, right? Once a quarter. It's going to go through the roof, right? You don't want to downsize that, right? You got to bring your knowledge of your business together with the data here. Bring that together because you don't want to short somebody, especially the finance people. They get very upset, right? So you just bring your business knowledge with the data here, and then you get your right sizing and squeeze every drop of blood from that stone. Cool? Sorry, Meg, I just can't.
What about the projection on the upper and the lower bounds then? Wouldn't they take care of the situation that you're talking about?
There's data, and then there's politics. So
Gotcha. All right. So as you can see from my picture here, I got the Linux Dev 0010. It might be 11 that I'm not sure. So that's oversized. So it has too many resources. I gave it 4 CPUs and 16 gigs of RAM, and it's not doing anything. And Ops is finding out of that. And it wants to resize it. And the same it goes for the undersized. If I go to undersized, on top here.
real quick, Ben.
Yeah.
Go back to oversized.
Yeah,
Notice
sorry.
how the recommendation for what it wanted to take away, it's exactly half. Because that's the most it's ever going to recommend in any given cycle.
Awesome. And as you pinpointed this morning, William, if you wanted to have a look on, for example, this Linux Dev 001, you can just click on it, and you get into the object browser where I can sort of have a look on everything that has to do with this little VM. And I even see that it's located in a policy here, and I can see how it's going with it, with the CPU demand. And I have to scroll a little bit further down here. It'll look very, very little done. You see that we only rebooted it, but for other VMs that have been booted for a long time, that'll be another ball game.
And I mentioned it earlier, but you see here, show history for, it's currently set for 1 month, and it's forecasting out 3 months. So those are two variables that you can change to either give you more data as part of that analysis, or to actually make it more of a kind of point-in-time analysis.
Yeah. So this is where you can sort of fiddle with the forecasting and say that, well, we can actually forecast for 12 months in the future. And then you can, most often VMs are demanding more and more, and you can see where in the future will hit the top line, which is the resources you have available.
And building on the question we had earlier, can this be used for individual hosts or clusters? And the answer is yes, and that's typically where I see customers using this forecasting right here, where they say, okay, based on my cluster utilization for the last 3 months, when do I need to place an order for a new one? Or do I even need to place an order this year based on the current growth over the last 3, 6, 9 months, et cetera?
And as you can see from my cluster memory demand, it's already way over what we are sort of having as resources. It's a pod, it's set resources, it's nulled out, so. Right, let's go back to the optimize and right-sizing. What we are going to do now is just to try to right-size one. And let's pick something from the workload cluster, not from the management cluster. We can pick both if we want to. And if you then click resize, then it will sort of give you the suggestion that William said about 50% up or down. So you can see that the decreased CPU from 2, that's exactly the half. Decreased 16 to 8 gigs, well, it used to have just 1 gig, but that have to come on a later recommendation. So that's why we say that this is a constant process. And you have to repeat this from time to time. Well, operations will do that for you. So you don't have to do anything. You just have to have a look from time to time on the right-sizing.
Now, it does give you the ability to modify the recommendation. There's a pencil next to each of the values there. So that's where you can apply your business intelligence and say, okay, yeah, I know you say I need to take away 8 gigs of RAM, but I know every quarter this thing is going to get hammered by the rollup report or whatnot.
I'm not going to do that. Instead, I'm going to go over to the schedule action because I need to do this in the future. I'm not going to do that manually every time. I would like to schedule this in the future, and that I can do. I can just, give a fictitious date, some days from now, for example, Sunday, and then say that, well, I understand that to make this resizing, to make this downsizing of this VM, it needs to be turned off, edited, turned on again. So if we understand that, then we can schedule it. So then when I create this schedule, I get a job name, yeah, sorry. I'll give a very, very nice job name. So now, if we go to the automation central, which is down on the left there, I can see everything in a calendar that sort of has been scheduled. And as you can see on my Sunday where I scheduled stuff, it'll have delete snapshots, delete snapshots, delete snapshots. There's something already there that is not mine. Well, I'm not going to let anyone do anything to my environment that I haven't created. So I have to go over to jobs here to take a look on what's going on here. All right, so we have a delete snapshots job there. Let's just delete that one. And here we have my beautifully named downsizing. And as you can see now, I only have my little schedule thing going on here. So now I've done something to to do something in the future when I have time on a sort of a downtime schedule. But let's do this forever. Let's not fiddle around. Let's make sure that we do right-sizing as a regular task. Was there a question, William?
Yeah, so the question was, how do we handle those VMs that do have those periodic spikes where we know that if we don't give them enough resources, we're going to get the ticket or the phone call or people are going to be complaining? And you do have the ability, as Bent was saying, to have the recommendation either be more conservative or more aggressive. What I've seen people typically do is they know they have problem child VMs and they decide, you know what, I'm not going to worry about trying to right size those or resize them. I'm just going to leave them as they are. And then I'm going to focus my efforts on the remaining VMs in my cluster. The idea of I could spend all my time fighting with the application owner on that one VM, and once a month I'm going to get yelled at, or I can spend my time and effort right-sizing all the other VMs in the environment. Your mileage is going to vary on that one. If you've got a very large environment, probably not going to move the needle, one particular VM or even a handful of VMs. But if you've got hundreds of VMs that are oversized and undersized, and you can go and tackle 50, 60, 70% of them, that will have a dramatic impact on your environment overall.
And plus what you're saying is that you can go ahead and exclude those VMs from this reckoning. So I was going to do something more with that automation central. And I was going to add a job here. And I would like a job to occur every week. And in that day in the week, I would like to resize or downsize everything. So what I'm doing, just create a new job and call it downsize or some reasonable name. And I will then downsize oversized VMs. And downsize what? I can downsize both virtual CPUs and memory. And you can do the default recommendations or only the 50% of the recommendation, as we have been saying all the time. All right, and again, just make sure that you have understood that this requires a reboot and whatnot. Haven't I selected? Yeah, okay. My keyboard is tricky. Now, the scope. What scope should that be? Well, this can be the whole clusters. So instead of saying that this and that VM is going to be downsized or upsized or whatnot, we'll do this to the whole workload cluster. So I have to just expand everything that we have under my vCenter, and then go to that region, and then find our cluster a little bit further down on the list, and drag and drop that onto the scope. Now, that's not the whole truth. So if I go now and preview my scope, there will be servers in here that I would not like to resize, but still it's on the list, and you can see our dev and Ubuntu and Windows is on the list. But there are other servers that I don't like to be resized, and these have an OS of Photon OS. So, okay, extend my time. Nearly there, are we? So we close this, and then we will sort of filter this criteria and go to next. And then I say that the object type is virtual machine, of course. And I will say that the properties of this machine should have the OS name. No, this is not one. Sorry. OS. Guest OS from vCenter. That's the name I'm looking for. And it can contain, or it can start with, or something. If it contains Win, for example, for Windows, well, put that into the loop. I will not add another criteria set and do the same, but only select Ubuntu as my property. Again, guest OS name. This keyboard is not good. And starts with, we can use that now. Starts with Ubuntu. Now, let's see what happens now if I do the preview on this one. Oh, that's better. So now I only got my Windows, my Linux servers, and it has those who are called Linux Dev is also there because that's also Ubuntu on them. So these are the servers that will be under this resizing regime that I'm creating. So the next one is just to select some time in the future when we want like to start, a week from now, and have it as not a daily task, maybe a weekly task or a monthly, or maybe even every 4 months. Put it on Sunday, take away Monday, and do this on that time. Create that. Now what we got? We have to look into the future. We have to look into next months to see this.
So real quick, under the filter criteria, we did this current filtering by the OS name, but all the other metrics and properties are available for you to be able to create your filter criteria. So you could look at a metric and say, anytime CPU utilization is greater than 90%, don't pick those VMs. So to answer the question, what do we do for those VMs that are getting hammered once a month? Well, you could have this be run every week, and if that VM is in one of those high utilization periods, then you could have it not action upon those virtual machines as they are having issues in that environment. So, and it's simple and/or operations, so you can build a logic tree on how you want those VMs to be actioned upon.
For example, you could have all the servers that are over a certain amount of gigs could be one of the criteria. It needs to have over 32 gigs of RAM before you can sort of be considered to downsize. Right, so this is all about the automation of the Rightsizing. And you can do other stuff like delete the snapshots and so on, so you can sort of save yourself resources. A gentleman in the back who wants to have a question. So you can save yourself resources automatically by doing this. The last thing that we are going to have a look at is how will we go about in the policies to sort of tune those settings that we talked about initially. How do we go and tune that in a policy where we set the upper bounds and the aggressive levels and whatnot? And that's what we're going to do now. So first of all, I would just like to search for one of those that were included here now in our scenario here. For example, this Windows 0010, that was included in my scenario here. And I'm going to have a look on that to see what policy does it belong to. And as you can see on top right there, it belongs to the vSphere solution default policy. Let's click on that and see view policy. And when you get into this, you get straight on to the policy, and we can start editing the policy here. If I just hide that one for a little while, I can see all my policies, and I can see the hierarchy of policies as well. And priority beats hierarchy here. So hierarchy is an inheritance. So you see on top here, we have config wizard based policies. And these are inherited underneath this one. So whatever is in this policy is affecting, and what's in this policy is affecting. But if someone is prioritized, like 1 on top and 2 and 3 and so forth, then that sort of trumps the whole thing. So you have that as number 1. We only have one active and default policy, as you can see on bottom here, active D. So we click on that policy, and we click on edit policy. And we are going to go onto capacity here and have a look at the capacity settings here. And you see on top there, we have that time remaining thing going on there. We also have settings for allocation, and we have business hours. And we're going to have a look on the top one first. So we have to go on top here and to the right here and drop down that. And to open these settings, we need to unlock it by clicking on that lock and key thing on top left there. And then we suddenly get into familiar images here. On the right is the image that I showed you in the beginning. And in the middle, you can see that I can set the conservative or aggressive. Aggressive being, well, we have our resources longer, but we are taking more chance. Conservative being that the upper band, you see that it hits the top there. The upper band actually is the one that we're looking at. So if I click on aggressive, you can see that, well, boom, it sort of extends the time, and we're only talking about the medium type of projection for this. And here you go. For conservative, you can set a conservative level as well. So if you are super conservative, it's 5, and if you're not conservative so much, then it's 1. And this sort of widens that upper and lower bound levels a bit. You can read more about this in the manuals. It's really interesting. Well, and you also have this peak-focused thing. That works for both these models. So if you have peaks that are peaking up to the upper band, this is where you would sort of click on this to make that count. So peaks would sort of be interesting for the projection. It's all about the projection here. How will this go in the future? So if you set super conservative and level 5, we can see that the upper bounds is moving, and the earlier we will tell ourselves whenever we hit the fan on top. So you can leave it on what you like. I'll leave it on super conservative, or I even go super aggressive, and make sure that in the future I will only go on aggressive level to use my resources the hardest way I can. Now, the business hours, that's quite a fine little thing, because you don't have to look on all of these things outside the business hours. It's only the business hours that are being used then for the projection. So if you put on business hours there, then you will sort of have the projections within your business hours, and we don't care about what happens outside, like the super backup or the something snapshotting or something happening to it. So we'll just take into consideration what's happening within our business hours, which is a normal, healthy thing to do. Again, you have to sort of open this up. Then if you have the same business hours every day, just move these slides here. This is our business hours, and then you can just put in these business hours for everything and say that, well, set all. Then you set for all of the days in the week. So now we're getting to fine-tune our capacity settings a lot more than we had before. Before we went for the default. Now we're going for the default. Now we sort of tweak this. And remember now, we have just one policy, and we should have had more than one policy. Maybe we should have one policy for developers, one for the super duper production, and one for something else. Maybe we should have one for active servers like the SQL servers and the Exchange servers and whatnot, because they are taking all of my memory at all times, you know. So it could be that we have different type of policies for a different type of usage. And then it is, well, you just say to the policy in the end, where is this going to work? For who is this going to work? And you can add that policy to the group of server or applications that you need to, and make sure that you have the correct policy with the correct settings for those type of servers that are within that application, for example. So, well, one policy does not fit all. And that's our mantra in VMware. There is just one policy in the beginning. That's a default policy. And that should be sort of a catch-all policy if there are no other policies defined, which have a hierarchy with sort of a numbering on it, which have something to say for one of these settings, for example, the business hours. So whenever you hit the policy, you get that. If you're not hitting any policy, you will get the default policy, which is this one. Now, is there anything else we would like to say about this? Well, yeah. Time remaining. Of course, we can set time remaining for our vCenter, for our cluster, for our other resources that we have in this environment. And we can open up the time remaining whenever we would like a warning or a sort of when we reach the threshold, what's going to happen. And you can see that there's a number there. That's days. So give us a warning before and within the 30 next days if there is something happening. So we have 30 days to fix problems. If you set that to 0, then you sort of say that when we run out of capacity, then we're done. We don't have any more. Then you should have some backup to sort of sort out your resource needs. Because if you don't give yourself a little slack, then well, you will run out and then you have nothing. So if you say 180 for warning, then well, You need to be projected 180 days into the future and then hit the fan instead of now, which is 0. So this is a good settings to make sure that you have the warning level, you have the critical level set for when do you need to be warned about this or not. So these are basically all the policy settings that we should need for our environment to sort of tweak the settings accordingly to these images that we show you in the beginning.
Okay, I got a question for you all then. What is more impactful to a cluster, a VM that is undersized or oversized? If it's oversized, raise your hand. Everybody should be raising your hand. Okay, I got 1 or 2 of you. All right, awesome. An oversized VM is going to be way more impactful for the health of a cluster than an undersized VM. It is taking resources away from other virtual machines that may need it, especially when it comes to CPU. The hypervisor has a harder time scheduling VMs that have larger numbers of CPU counts. So when your database team comes to you and says they need a 64-core VM, tell them no. They do not need it, and it will impact everybody else on the cluster, okay?
So the reason for that is, of course, if you have a machine with a demand for 16 virtual CPUs, you need basically 16 cores for that VM from time to time. And that is also if that thing is idling and not doing anything. From time to time, that VM actually need these cores to at the same time actually, to have those cores available for it to make something happen, which is nothing. And it takes away the power from all the other ones. You had a question.
Pass you the mic here.
This is probably more of a political thing, but if it's a software development company where their minimum requirements and where they have to test is 32 CPUs, that's just political basically, right?
My experience with those requirements that you get from a software company is they've done testing internally where they have basically determined that we have a 100% guarantee to have this work in your environment if you give us 32 gigs of RAM. In reality, they don't need that, but that's a way for them to cut down on support tickets or help desk issues. It's like Windows. You can run Windows on 4 gigs of RAM, but a lot of people want way more than that. Well, the more resources you give it, the less likely you are to run into an issue in your environment. So, to your question, software vendor says they need 32 gigs of RAM. You could start off giving them 32 gigs of RAM, and then you could analyze the performance of that virtual machine, and then you can go back to them and actually have hard empirical data to say, hey, you're not utilizing any of the resources that we've provided to you. We're going to go ahead and in a step-down measured approach, we're going to take away 2 gigs every other week. And you could step them down from 32 until you eventually get down to a happy medium where the performance hasn't dropped off, but you haven't given them everything they've wanted at the same time. So, to your point, it's somewhat of a political question because you are going to have to negotiate with that vendor, especially some EMR vendors are going to have, and that's electronic medical record vendors, they're going to have hard requirements. They're going to say, we won't even provide support to you unless you have a certain amount of resources. My patch has fallen off. Thank you. For those VMs and those vendors, you're going to have to take data to them. To saying, no, we don't think you need to use that, you're probably going to lose that argument. But if you're able to show them, you guys are idling at 15% utilization, you have a spike once a day to 30%, we don't need to have all these resources being wasted, it's a lot easier to have that conversation.
I agree with you, it is political. And the smallest thing about that is when you have application owners telling you that they need 32 gigs of RAM and at least 16 virtual CPUs because page 10 in the installation manual says so. And that's sort of not understanding virtualization, after my opinion. So there are many ways you can do this. Me coming from Norway, we had Norwegian tax, which is heavy users of Aria, anything and whatnot. And they sort of went on with automation. And they said to everyone, from today, if you want this beautiful automation that we have, you need to also right-size. So they also had this understanding people telling them all the time that can't touch it. You can't have anything of my resources. If any, I should have more. But then they did that sort of soft, went in soft and tried to make this turn around, and they did. So after 2 years' time, everything was under resizing. So it is possible to sort of tweak the knobs maybe to make this happen. Just need to be clever, I think, to find the correct way for your company. But as you say, and developers are saying to you that, well, this is how it is, and then go William's way to sort of take it down.
Since we have some time, do you mind? There was a metric chart that I always build out when somebody says, I need more CPU, more memory. I'll show you guys a quick trick. Do you mind?
Yeah, go.
Cool, thanks, man. So I love this new troubleshooting here. And this is the thing that I made a dashboard out of this eventually. But this is what I like to do. Let's see, troubleshoot. No, where's the troubleshooting workbench? Why am I lost? There it is. Okay, so we'll go to Linux, right? Some guy came up and said, hey, my Linux machine needs more CPU or more memory, right? So I love this troubleshooting workbench because it puts everything right here for you. You can zoom out your scope, which is, host, data store, whatever. You can zoom it back in. Depending on what, do you have a systemic problem or do you have a single problem with this VM? But what I like to do, guys, is I'll go into metrics, come over here, go to CPU, and this is just real quick, right? You're gonna build out what is this thing using, right? So do workload for a CPU, and then go down to memory, same thing. Go down to workload for memory. And you just get a little window into what this guy's been doing for the last little bit, right? I like to throw in network, like what's the drop packets or just the overall usage rate, right? And then you can get into, when you get into metrics, your storage, you have a couple of things. You can do the storage array, I like to do the VM disk because that's the closest to the VM. And then you can do total IOPS or something like that, right? But basically what you have is you have CPU, memory, network, and then the disk rates, right? And then what you can do in here is you can zoom all the charts at the same time, and then you can draw a window here, and then go in and see what's going on. It zooms all those in there. So you could say, okay, when was this guy slow? Was it slow last Saturday? All right, let's zoom in on Saturday, and you can say this thing hasn't gone over 50% CPU in a month. You don't need more CPUs. That's how I would always win the arguments with the OS admins. And just show them this is a very easy, consumable way to do it, and you're not getting into any VM jargon. The one caveat is you need to understand the numbers that VROps is showing you. So do some studying about what's going on because, for example, memory, right? We track ones changing to zeros and zeros changing to one, right? But if you go to an OS admin, he's like, my swap file says I'm using 4 gigs. That says I'm not using anything. You have to defend that, right? So just understand the numbers that VROps, Aria Operations, is giving you, and then you can win this over and over and over again. And this is really going to let you get every drop of blood off that stone.
And a good thing about what you're showing here is the correlation between all of these metrics and how many metrics do you need to sort of prove that your VM is having any problems anywhere. Well, dropped packets, memory contention, CPU contention, and not IOPS maybe, but at least latency, disk latency. So these 4 parameters are really.
Yeah, that's really why I love this troubleshooting workbench, because if you can get blinders on troubleshooting a VM when you have a storage problem, you have a systemic problem within your infrastructure, right? So this allows you to zoom out, and then you get these indicators right here. You can see that this is alarming on the host system, right? So it allows you in one stop shop. I've never been a dashboard user. I always like to create my own like that, but they've really done a nice job with this troubleshooting workbench. I like it.
It is a forensics machine.
It is. It really is. Yep. But that's 90% of my arguments right there. That would get them to go away. Go look at your code. It's not the VM. Right. Thanks, Meg. Sorry to hijack.
Awesome. Like it.
What is the like a VM system performance are you shooting for really? I mean, like we try to shoot ours in we're in like 60 to 80% range constant utilization, but is there any kind of like good numbers with a VM performance data to show what you're trying to aim for when you're undersizing or right-sizing a box?
Are you talking from a RAM utilization, CPU? I don't think there's a good hard answer on that one, because some of it's going to come down to the availability requirements you've also baked into your environment. Let's say you have a stretch cluster, and so you need to be able to fail over all your workloads from one site to another. Well, in that case, you're going to want to have 50% capacity remaining at any given time, so you could fail everything over. Or you may decide that, these are non-production VMs, this is our dev or our QA environment, so I don't care if it's running at 95% capacity. I have a customer who their mentality is, from a failover or DR event, we'd rather have our VMs be up and running but degraded than be down. And so for them, they don't worry so much about maintaining a buffer to be able to fail workloads over and start them up. Their stance is, I'm up and running even if it's at a poor performance value. That's all I care about. My rule of thumb is, anytime you get above about a 70% utilization on RAM or CPU, that's a time you should start making those decisions. Do I want to add additional capacity? Do I want to start right-sizing workloads down? That's my personal rule of thumb. But there is really no official stance out there. It's kind of it depends question.
And I think that you can do sort of performance policies for this. So you sort of create your policies with the performance in mind, so you can sort of fulfill your SLA that you're actually talking about. So use the policies for that and make sure that everything that you have within the policy is supporting you in actually doing the performance SLA.
Does that answer your question? I know the it depends is always kind of a vague answer, but in a lot of cases, it does depend.
It's just from the stance, like you said, you had the database server had 32 CPUs, right? And you're looking at the performance chart, and it's 20% utilized, and you're telling the database guy, we need to cut your CPUs down because we want to see that running in that, like I said, 60 to 80% range all the time versus just idling at 20 to 30. So I mean, it's just, like I said, I'm just trying to see if there's like a good workload when you look at this to see if that,
It's time to ask the database administrator for budget.
That's why you should study another module that we have that has to do with cost. That's really good.
So one of the things you can do in that case is look at the metrics and say, have there been any spikes or utilization that does justify that 32 vCPUs? If throughout the last 6 months they've never utilized more than 50% of capacity that you've allocated to them, they don't need 32 vCPUs. They may want it. The database vendor or software vendor may say they require it, but the empirical data says otherwise. Now, will you be able to convince said database administrator or software vendor that you can shrink them down? I would hope to say yes, but the reality is it's one of those, it's a political question in a lot of cases.
Maybe databases isn't the first attack point. Maybe resizing the low-hanging fruits is the ones that you should do, because every time you do resizing, you're giving back more to the society that actually will make everything run better. So having these kind of policies is maybe not for exactly database servers, but maybe other type of servers. Yeah.
One of my customers has a policy, and part of the filter criteria they created was the VM utilization had to be below 10% for, I believe it was 90 days. The idea is these are idle VMs that are basically wasting space. Let's go ahead and cut their knees out from under them because they don't utilize any of the resources at all. Any other questions? All right, well, if you all haven't completed the lab, you can spend the rest of the time here to go ahead and work through the lab. We're here to answer any other questions if you want, and let us know if you need anything. Thank you, everybody.